we have to add that last, I mean, add that?
Okay,
four
you know
or
what,
five?
what I do in my calculator is I just leave everything in the calculator and I don't do any actual rounding. But just so you kind of follow along, I put these things up on the board, okay? What is my test statistic?
2.7.
Yeah, okay, so we're going to do what we observed minus what is written in the null hypothesis divided by our standard error. What did I observe? Yeah, the average weight of my 30 tomatoes was 5.9 ounces. What is written in my null hypothesis? 5.0 ounces. And my standard error is 0.32863 something something something. So when I do this, I'm just I'm doing 5.9 minus 5.0 in parentheses divided by answer. I get 2.7386. So I'm just going to write 2.739.
Okay, if we had like 2.7388 and put that on the
Whatever.
test,
Okay, 7388, 739. It's like the same thing to me. Okay.
Okay.
I don't care. Okay. On the final exam, when it's multiple choice, maybe you'll see 2.739. If you got 2.7388 on your calculator, pick 2.739. Okay. So just go with that. Okay. All right. So how do we do the p-value here? Well, I got to figure out my degrees of freedom. So how many degrees of freedom do I have? 29 degrees of freedom. So if I go to the row 29 degrees of freedom, and I'm looking at these numbers, towards the end I have 2.462 and 2.756, and that's it, okay? Where does 2.739 fit? It fits in between here and here, okay? So 2.739 is in between this number and this number. If it was exactly this number, how much would be my p-value?
0.001.
Okay, so...
I mean, no, 0.0.
Yeah, okay, so
1.
again, because it's a two-tailed test, I'm going to use the numbers that correspond to the two-tailed probability. So this corresponds to 0.01, and this one corresponds to 0.02. Are we satisfied with that?
Yes.
So my test statistic is in between these two numbers, so my p-value, I don't know exactly what it is, but it's going to be in between 0.01 and 0.02. And because this number is really close to this number, it's probably going to be really close to 0.01. But whatever, okay? So my p-value is less than 0.02, but more than 0.01. So what conclusion do I make?
You reject.
I reject the null because my p-value is my p-value less than alpha, which is 0.05.
Yes.
Yes, my p-value is indeed less than alpha. Alpha is 0.05. My p-value, whatever it is, it's in between 1 and 2%. So my p-value is less than alpha, so I reject the null hypothesis. And what does that mean?
That we have evidence that the average weight of tomatoes is not 5 pounds.
Exactly, okay? You don't have to be hesitant. You got it exactly right, all right? We have evidence that the average weight of a tomato is not 5 ounces. So the fact that my 30 tomatoes had an average weight of 5.9 ounces with a standard deviation of 1.8 ounces, the fact that it's 5.9 ounces is enough evidence for us to say the average weight is not 5.0 ounces. Okay? So in the last example, the fact that the Norwegian male, the samples was 71 inches versus 72 inches, that was not enough evidence. Okay? But here, 5.9 versus 5.0, that is enough evidence to say it's not 5 ounces. Yes?
Why do you use 29 instead of 30?
Why did I use 29 degrees of freedom?
Yeah.
Okay, how do we determine degrees of freedom when we're dealing with this? N minus 1, N minus 1. Yeah, there's a lot to keep track of, and so sometimes you forget one of these things along the way. So yeah, degrees of freedom is N minus 1, so that's why I'm using 29. Okay. Yeah, I know, there's a lot to remember in these things. Okay, how's that? Not too awful, right? Not too awful. Alright, why don't we take a break? We'll come back in like 10 minutes and we'll finish off chapter 9.